Hello, everyone, and welcome to Handmade Hero, show where we code a complete game live on stream. We are going to start doing our asset tag matching stuff today, where we were just cleaning up that system, and I think we had a really simple way of just making it nice, so we're just going to finish doing that and start kind of poking around with the implications. Before we get started, I did want to mention at Molly Rocket, we do have a sale for the holidays on, the Infinite. So if you are in the mood for cat space adventures, or space cat adventures, if you will, all of the stuff is on sale, as you can see here. And in fact, I've got one on my desk even. You can see it. It's like a really, really good, it came out fantastic. Like, we could not be happier with how good this thing looks. The printers we worked with on this were absolutely fantastic. So if you're looking for some cat space adventures this holiday season for you or the, space and or cat lovers in your family, we've got you covered. And that's just meowtheinfinite.com. You can also find it on mollyrocket.com. In fact, you can even find little buttons at the bottom of our page now. I finally started to clean this stuff up. I haven't really had a chance to do it all yet, though, but our sites will slowly converge on something more usable, so that should hopefully be good. International shipping included? No. Domestic shipping is included. International shipping isn't included because international shipping is so expensive these days that it's more than the entire cost of, like, the entire price. Like, it's often $20 or more to ship something to ship a 1 pound book, which is what it is. So, like, yeah, international shipping is fantastically expensive. Probably for good reason. I mean, I'm sure it just takes, like, we don't have low fuel transport solved yet. So I'm sure it's just very expensive to get something from one place to another, even if it's fairly light. As long as it is a package of some kind and not just a, infinitely thin little letter or something. I'm assuming that there's just no way to get that price down to, like, reasonable price. Domestic shipping is already quite expensive. It's $10 at least, but the international is ridiculous. It's like 20 or something. And so it's ridiculous when you think about just how expensive that is compared to the cost of the actual product, right? But that's just how it is, right? Someday, hopefully, they'll get that down because it's nice to have physical goods, but, they're difficult to move around. All right, so let's go ahead and get started. I am going to go ahead and switch to Handmade code directory and get us back into 4Coder. So, also, I'm going to turn off I got to put in an automatic toggle for the cursor trails. So, essentially where we left off, I believe we left a compiler error in, right? Yeah. So, essentially where we left off is when we go to get an asset, previously what we'd been doing is we'd been taking the tags that we got as vectors, and we would basically say, look, for each tag, you've got a, like, you had like a weight for how heavily you wanted to match that tag, and then you also had like whether or not, what the particular tag was and whatever. And that was just kind of ridiculous because we didn't really need it. Like, it was massively over generalized for what we ended up needing in the asset system. That system's been in there since, like, really, really early on. It's just the first thing we threw in. And now that we know, like, what the actual situation is, it's, we should go ahead and make sure we've got something reasonable. Like, so we want to make sure that we have something that aligns with the actual asset lookups we need to do. Otherwise, we're just wasting a bunch of time and adding complexity and difficulty into the system for no reason. So what we want to do here is we want to change from this system where we're passing this match vector and instead just using the tag hash. So I believe we want to just get rid of this entirely, right? So if we look down at, like, when we do get bitmap and so on, what we want to do is change these to just take asset tag hashes. And then the match vector, oh, I guess we already did change it to a v4. So it's only this one that's wrong. So then the match vector is just going to be the thing that looks up into like the grid, right? So what we're going to assume is that, you know, there's essentially a tag hash which tells you which source template you were looking at. So, for example, you know, it would identify roughly the PNG that you're looking at. And then the match vector would be something that tells you, okay, inside that specific PNG, what were you actually going to pull out of it, right? And so the tag hash basically tells you what, and the match vector tells you which. And since we don't want to have to worry about exactly how the art assets are created in this sense, what we want to do is make it so that the tag hash itself, when you look up and you find the asset in question, we want that asset to tell you which portion of the match vector it should be extracting, right? So the match vector that we pass in will now, instead of being some big sprawling thing, is just always going to be fixed v4, and it will have in it a couple different parameters that you can pull out for matching. And there'll be things like facing direction and expression or something. So like facing direction, expression, and, you know, variant maybe. I don't know what they would be, but there'd be like 3 or 4 things in there, right? And then when we look up in the tag hash, you would apply the match vector by at the tag hash would tell you how to, you know, grab the pieces of the match vector that you actually need, if that makes sense. So looking at this, the first thing we need to do is just say, all right, so if we're going by asset tag hash, then, you know, this also needs to be a v4. It's not going to be an asset match vector. And in fact, asset match vector would not really be a thing anymore. So these are just not going to be important anymore, I don't think, unless we already changed it and I'm misremembering. Because, oh, well, no, you know what? I think I think maybe we changed it to this already just so we could have an integer that lines up, right? So that this code doesn't have to be the thing that changes floats to ints as they come in. We just assume that the code on the outside like did the mapping, did the truncation to the correct values. So yeah, I guess that's just basically saying, look, it's picking it out from this set. So it's really this one that we want to change, like so. And the same would be true from basically everything else. So instead of having asset vector, which would not exist anymore, and I don't know if that still does, it does. So instead of these ridiculous things which are unwieldy and terrible, we're just going to get rid of those, and now everybody who does a match will always take just the tag hash and a match vector, and that's what they'll use from now on. And you won't need the basic category anymore either. And we also don't call like this get random bitmap from, so we'll just, you know, get rid of it. We can always add them back in, but it wouldn't look like that anyway. That wasn't like an important piece of code to save. So I also don't know like if get first bitmap in this case is relevant anyway. Like, I don't know if we ever actually use that. I don't know. Can I search for a string? Get first sound or bitmap from. So I don't see any evidence that that ever gets used anyway. So I think we should be able to get rid of that. Whether get first sound from exists doesn't look like it. So I'm guessing that we can just actually stick with real matching at the moment. So I'm hoping that we can just, you know, do something like this, where everybody now will take the tag hash and the match vector, and we will be able to always just pass those through and have the matching system work fairly straightforward. So the only thing I'm not sure about is, since fonts are kind of a special case because what gets pulled out of there is just characters, obviously the match vector, weight vector nonsense wouldn't really make any sense. I don't know why we would want to bother with that, but it may be the case that just this system still sort of works. So for the immediate, for just the immediate test, I'm going to assume that we can still use this way, but since we're in the process of optimizing, if it turns out that that looks a little too onerous, if it turns out that I don't like the look of that, we may make the font code take something different on purpose there. So assuming that we call get best match asset from, if that's just now going to be called get asset from, because we're not really doing a best match anymore, it's a direct lookup, or at least close to a direct lookup, then now these functions are all correct, and really we're just talking about this one now, right? And what we'd like to do is we would like to go ahead and make it so that it's very clear what happens when we, you could even see that we've sketched it out. Unlike the old one, we want to make it very clear what happens when we go to look up an asset. We want that to produce a result extremely quickly. So what you can see, what we did here is we said, all right, so suppose we take the tag hash, which is like a pre-hashed value, right? And then we take the match vector, which is like additional information. So like the tag hash, right, is something that would be, when you actually specify it, you can pre-hash that and just store the hashed result. But the match vector has to vary like per frame. So if you imagine something like facing direction, when the character's like turning around and such, it's going to change what's in that match vector. So effectively what we're doing here is we're passing in almost like a partial hash. And then we're passing in like an additional part to go into the hash. So then what we do is we're pulling out pieces of the hash, right? So we're basically saying we're going to take these things and then we're going to hash those together like so, right? And the thing that, strikes me about this is, honestly, I'm not sure that we really need to bother. So if we take a look at like what happens in something like hash 32, what you can see is we are already doing a fold here where we do where we mix in I'm not sure how to say this correctly. So what you can see here is we've got our hash set up so that we start with an initial value, which is these two U64s. And then we're going to like run it through AES-DEC to like basically, permute those values and turn them into a fairly randomly distributed set of bits that's still unique to the input values. But my question here is just, should we just go ahead and make that be something that happens for all of the input values? Because if we assume that there is a limited number of these match vector entries that are actually important, like we've done here where we said, well, we're just going to put 4 of them in there total anyway. If that's the case, then why not just hash that in with it, So, for example, in here where we have this value and this value, what's going to happen with AES-DEC, for example, right, is AES-DEC is effectively bit scrambling in an XOR. So it will do the bit scramble. In fact, I can show you maybe in the Intel Intrinsics guide. I don't know if it actually will show us or not. Yeah. So what you can see here is the action of this instruction is it's going to do a bunch of bit like randomization, right? So it's going to like shuffle the bits around all over the place. like so. And then it's going to XOR in whatever the extra parameter was, right? So it's the shuffling that we really care about. We don't care about the XORing, but the nice part about the XORing is that what we could do is XOR in the other values, right? So I don't know how strong of a hash we actually want to have here, but for example, what we can do is instead of folding in the seed like so, what we could do here is fold in an additional value, right? So, because we know we really want this to be, like I said, something that wants to be really efficient, what we can do is just say, why don't you just pass us, like, you know, the address to hash from, so something like, you know, I'm trying to think of like how we were doing that tag hash. So if we did something more like this, so we said there's an extra like 128 bit, so there's you know, like, not sure what to call this, but something like the extra 16 byte thing to fold in here. It would just be like, it's not free, but it's like close to free. Right? So we can do this where we effectively say, if you want us to hash 200, you know, in a sense, 2 match vectors, right? We can do that for you. You know what I'm saying? So especially another thing we could do is say, like, you know, if we said this, right? Now what you could do is say that there's 2 match vectors, one that's got the hashes in it, and the other that's, you know, something else, right? And so we may even want this to be a like a very specific kind of function that actually takes, you know, something specific here, and I'm not sure. Again, I'm not sure exactly how we want stuff to flow to that, but this would give us a fairly well-distributed hash from any 2 128-bit values like that. And so, you know, let's just see about what we're gonna pass here. So where are we actually? So here's where we're actually doing this, right? So you can see like an example of us producing these values, like the, you know, weight vectors and whatever else garbage that we're making here. And then you can see us calling the get best match bitmap. So we know we're gonna come into here with some kind of a tag combination, right? So it's going to be like a bunch of tags that we combine together. And just looking at that, you know, yeah, it seems like we're probably just going to want to store I mean, it's really just pretty straightforward for us to just store these as hashes. So I feel like what we want to do is almost introduce just this hash type as a thing. Because these tags as well are, you know, when we're doing these tags, what are they going to be? Like, they might be just like a series of 16s or something. And so I feel like we maybe just want to make this a little bit more general. So, like, maybe we pull this out, actually, and we go into here, oops, into the intrinsics, and we maybe, you know, make like a hash thing. I don't know. Like handmade hash. That sounds yeah. It's handmade hash. So if you imagine like a thing that's got the hash stuff in it, right? And you imagine that we think about this a little bit more, and you know, I could pull the intrinsic into the intrinsics file. We could have just a something here for bit scrambling. So you know, we make an intrinsic that's like bit scramble or something like this, and it would just need. I guess I don't know how we would be exposing that, because one of the problems that we have, yeah, we'll leave it maybe for a little bit later, because I feel like in SIMD we already kind of did put this stuff in there, right? So we probably want to unify those into, like, we want to put that stuff into a more centralized location at some point, but now is probably not the time to do it. But the point is, if you imagine something that looks like this. So we've got sort of a, you know, like a hash value, something like this. And we just assume that everyone uses this thing when they want to communicate with the hashing system. So you can stick 4 U32s in there, or 2, you know, of these, or even like for tags, for example, you can put 8 tags into one of them. And then what we would do is just, there's going to be a thing that says that if you give us any two of these that you've filled out, and we don't care like which, you know, what they are, we will produce like a well distributed hash from those. And you know, maybe these should be called like hashable value, in the sense that this is the things that you put in these are not hashed at all. They're just things that you bear stuck in there. And then you would pass a hashable value to one of these things, and like so, and it gives you back the 32-bit lookup value that you actually need, right? So if you want to do something like that, pretty straightforward. You don't have to use this set anymore. Instead, what we would do is we'd just say, okay, we are going to do the load. So we're going to take the value here. And in fact, to be honest, this really doesn't have to be here. We know how big the thing is, so it's really, that's fine. We're going to load it unaligned anyway. It doesn't need that additional piece of information, so we can just leave that be. So basically what we'll say is load the 128 bits out of this thing, which is the whole thing. Go ahead and munge it with the seed, like so. So, you know, go ahead and munge the value, and, well, ooh, that's a bug. In fact, why do we have 2? I don't even know why we have 2 of these. Like, why wouldn't this just be load the hash value and hash the hash value, right? Like so. So, yeah. I think that would be all we would really need. And, you know, maybe I was a little overzealous in making this a separate file. You know, I admit that. Because if we look at what this is doing, it's arguably a little bit stupid, right? Like, I mean, how simple is that? We don't really need a separate file for just these 2 things. So, you know, maybe we leave it around as an aspirational fantasy, in the sense that, you know, maybe we want to have in the future some more fancy hash stuff that we're going to use for, I don't know, like verifying a file or something like that. You know, there's obviously sort of bare arguments we could make about that. They're not probably good arguments, but, you know. What are you gonna do? So yeah, so I think that's probably good enough for now. And then what we can do is any place where we were previously going to do something like that, we can just sort of have, we can just sort of have that in there. So I think what that would generally mean is that, like, in this asset hash entry thing where we're going to have the hash table, all we're really going to do is, match against, I guess, the source hashable. So if we want to do, yeah, because this would have all of the information in there. So if we want to do it, we would just store the hashable in here and say that's the full set of things. So two 64-bit values is what we're going to match against. Because that should be able to uniquely identify the thing, because that would give you, assuming that you actually just kept everything as U16s, that would give you 8 values, which is like the 4 tags plus the 4 vector values, and that should just work, right? I mean, you could even get fancier and have, it by byte if you really wanted to. And that would allow us to do stuff like having the indexes be only 8 bits, so you could have more of them or more tags, right? So I don't know. Like, there's a number of different ways we could do this. I'm not sure which ones make sense. We could make this thing be a little bit clearer laid out as well in the future if we want to. I'm not sure. But we just would want to make sure that it's still the same basic 128-bit structure, because that's what we know we can hash quickly, right? So in here, what we'd like to do is just make sure that this thing now takes all of the hash stuff that we had before and just feeds it into here. So, but I think at that point, like, we literally just have, I don't know if we actually bothered to put in the hash in here yet. Looks like we already did, right? And when we say, does this need to be a prime hash, I'm not sure why we asked that question, because we must have not really been thinking particularly much about this, because obviously if we've gone through and done a well-distributed hash, then it doesn't need to be a prime hash, right? So I don't know why we would have thought that that would have needed to be a prime hash. It's a reasonable question, but I don't know the answer. The other thing that's interesting about this is we could, if we wanted to now, start to think about potentially eliminating the centralized asset store anyway. Like, we could just say that everything goes through the hash now. So as this becomes more powerful, we may decide to start eliminating some of these other things. This, for example, is now completely unnecessary. So we wouldn't need the tag arrays at all, I don't think, which would eliminate a huge bunch of complexity from the system. So that seems pretty good as well. Like, just looking through, what the... Yeah, like what... Just thinking about it, it seems like that would be pretty good. So I think that's all well and good. So let's go ahead and keep going from there. But this is a little suspect now, because you're like, well, can't we just, maybe we can just sort of store this stuff directly in there, is the thing I'm thinking. Like why do we actually need, like, this right here? We could just make that be the thing that's in the hash directly. And so I'm not sure why we wouldn't do that. In fact, I'm going to go ahead and say, let's just go ahead and do that, right? Because the only benefit, the only thing we would get is overmapping of tags. Well, so I guess we should probably do it without that first, because if you assume that there will be multiple tag sets that will all map to the same asset, then we would want this. right, we do want an indirection here because we want to be able to map multiple tags to the same asset. But my assumption would be that if we were going to do something like that, or if we are doing something like that currently, it's probably being done in more of like a range-based fashion, right? So we would be doing something like mapping a interval of hash values, and it seems like we can probably make that work in some other way. Like for the cases we actually care about, having an asset respond specifically in that way, I feel like it should be able to work, right? I mean, I could be wrong, but it feels like it should be able to work. So I guess here's what I will say. Maybe that's not true. Like, maybe I was a little bit overzealous here, and the previous thing was actually a little bit better. So think about this. So let's suppose that we had a entity that wants to map a bunch of different match vectors all to the same thing. If we go through the hash table for that, yeah, so all right. I will admit to being dumb here. Or rather, I will admit to being smarter in the past than I am in the present, right? So if we consider what was happening here with the asset, with having these two things be separate, then I guess the reason why this is actually a better idea, meaning why we would prefer this to the previous way of doing things, or the one that I just sketched out, is because if we actually do it this way and fix the bug, so don't leave the bug that was in there. So that part was a good change. If we leave it this way, so that we're taking in a tag hash, we're looking up a particular asset piece of information, and then we're matching against it or whatever. So I think we can safely remove the part where we can safely remove the part where we do packing or any of this stuff here. That doesn't have to happen. But what we would do is still do a tag hash lookup to figure out which, or more specifically, maybe we just use the tag hash to look up the hash line like we would normally do. We loop through those, and then we just match against the entire match vector as we go, right? So the hash entries are just like this sort of a thing. We don't do this, so we don't need to load a category. We just go ahead and take the hash of the thing that we actually get, right? We do not hash the coordinates at all, so those don't happen. We map into the tag array, the assets by tag table. We look up in there and we just step through each asset, looking to see which ones match. And that, I think, would just give us what we want, as long as the asset itself has a suppression field, right? So as long as the asset itself can mask off parts of the match vector that it doesn't care about, and it says I match everything in this part of the match vector, then I think it just works, right? So that's actually just fine. And then we, I'm sad to say, I'll go ahead and do the, the sad sort of like, where we delete our code that we just added. But it's okay. It was learning experience. So we don't actually need the hash. That's gone. But, you know, maybe it'll come back someday. Who knows? So, oh, whoops. I turned on power mode. I mean, power mode is excellent. Maybe we'll leave that on, but I'm going to turn off battery saver mode. So if we go back to get asset from, so yeah, so I think really all we have to do here is take the tag hash. Ooh, power mode is broken. It looks like. No, it's not. So I guess I'm not sure what was happening down at the base of the thing there, but, all right. So anyway, if we go ahead and so why is it, I wonder what's going on there. There must be a bug in power mode, which is terrible because power mode's like the most important part of everything. So what we want to do here is once we grab the hash slot in question, we just want to loop through the assets in that hash line. So in the asset system here, I need this to not, there we go. So if we loop through the assets in the system, like I said, we can probably say like, all right, we'll get rid of hash entry. And instead what we'll do is we'll pack the hash entry stuff directly into the assets so that we don't have to like hop around for no reason. And we'll go ahead and place these in here. So, you know, in addition to the stuff that we have for the asset, otherwise we'll have the match vector and the tag hash. And so those two will... those will just be there for us to sort of step through and grab. And so we need an ability to link to the next one. I don't think there's any reason we can't just use a pointer here. So we can just do like next in tag hash sort of a thing, right? And what we can do is grab the first one out. So we'll like, you know, loop through the assets that we want to check. This is called the assets by tag. Right, and we know it's the hash slot that we're looking up here. We would then just loop until we're done. And so that's all the stuff that we would actually need to loop over. I don't know, again, I don't know why ForCoder's indentation is all broken. I don't know if that's something that, you know, when that changed or what happened. Someone should tell me at some point what's going on with that. Because it used to do the right thing like that, and now it doesn't, I don't think. So I'm not sure what's going on there, but who knows? Anyway, so once in here, we just need to validate these two things. So if we match both of these, the match vector and the tag hash, then we're good. And the part that I was talking about before is like, essentially these are just going to be self-masking. So when you look up a particular asset, you're going to go ahead and say that that asset could, and this replaces sort of the fuzzy matching we had before, which is something that's much more concrete. We just need something that will mask these values, we just need something that will take these values and get rid of ones that we don't want, that are not important for this asset. So if the tag hash matches, it will then say, okay, let's build the appropriate match vector by trimming off the pieces that we don't care about. And so all we need is like an efficient way of like creating that mask. And to be honest, I'm not really sure what the efficient way is to create that mask. I guess we don't really need to think about it at the moment, but it's like, what you'd want to do is have a thing where you could load... You'd want to be able to load like a value out that would then select the lanes of like the 30-bit. You could probably do it pretty easily with like a shuffle. So like you'd load like the shuffle pattern for SSE or something like that, and you'd just like allow it to shuffle for you a thing that had, you know, imagine in SIMD loading something in that had 32-bit lanes where, like, you know, the first 32-bit lane is all ones and then the rest are zeros. And you just load in a shuffle pattern that says which to take for each lane. That could trivially replicate out, you know, ones, zeros, right? And then you just do the and. So I'm going to put a little to-do in here that basically says, like, to-do... the matching test could be done potentially quite efficiently in SIMD. And so we're going to say that there's like a, you know, some kind of a thing here that's like the shuffle pattern or the match pattern. And I'm not sure what the easiest way to do that would be, but I'm guessing what we want to do is just use like the pieces of that to tell us which one we're going to use. So, you know, you could imagine it basically being packed like something like every two, you know, like it's set up like that. You know what I'm saying? So, like, it's bitwise. It basically has, you know, 4 settings. It's which of, for each one corresponds to a piece of the match vector. And we could just say that, like, 0 or 1 in each of those bottom slots. So we could say, like, you know, probably want to do it in bit order, right? So we probably want something like that. And each one of those would tell us, like, whether we need to care about that particular match, right? So what we would do here is say, all right, we know we want to check the tag hash. So that has to match. So we'd say if the tag hash value that we were passed in equals the assets tag value, like so, then that's the first step. But then we also need to do a check, and we'll build the check here as well. We could just say, okay, we've got a match vector that is the, you know, the kind of neutered vector, if you will. Well, you know what I could do too is I could just do this. So we could just do this. We'd say for each of the indices in there, so for each of the elements that we're matching against, yeah. So for each of the elements that we're matching against in the tag hash, we want to look up the corresponding bit value in the match pattern, and make sure that we just don't bother with ones where it's 0. So we would say, like, you know, if you know, now I think about it, I might just write this out longhand because it's going to be easier. Yeah, I think I will. So it's going to be easier to write longhand, so let's just do it. So if we go ahead and take the match vector E0 and the check match vector, we can just write it like this. So we've got these two things, if they're equal, we just need something in here which also says, well, if the match pattern and, you know, 3, right, shifted down by however much we're on, that's the rule for each one of the elements, right? And so what we could do is say, all right, so there's, you know, matches, it's true, and, you know, I guess I can do this in a for loop if we want to write the explicit. This is one of the things that C sucks, is it can't have a for loop. For loops don't evaluate to a value, which, you know, much like if statements, it's just stupid. It's just a bad idea. But anyway, so you could basically say like, all right, we start with matches. We basically just like, and, you know, we want to take like, this is matches and, right? So we and in all of these, and then at the end, if we've got a match, then we're good to go, right? So we would say result equals whichever asset this actually is. And I guess one problem we have here is it looks like for pointer-wise, we want to know the asset index because we actually use the asset index itself. So we could just stuff the index in here, but, you know, in order to remain compliant, we could just do U32s here, right? So we could just say like U32 like check index, right? And then we would say like asset star asset equals get asset, and we would just say, you know, we want this one or something, right? So assuming that we want to do that, it's the same exact code. It's just we would need this, like this part has to come out, so you know this becomes a while loop because we can't access the variable that we need. So while check index is valid, we would just sort of chain through here. So we'd say, all right, loop over the indexes, and we pull them out as we go. There's a weird, so yeah, Ryan's not here today, is he? Well, doesn't sound like. So, yeah, I have to find out what's going on with that power mode. We'll have to take a look at it. But anyway, so if we loop through the different indexes here, then what we could do is just say like, all right, you know, we're gonna return this one. So it's pretty straightforward. So looping over these. Oops. So looping over these, we just check the pattern. We see whether or not these are valid based on whether or not the pattern says we should. So if the pattern is 0, then we will check them. If it's 1, then we won't, right? So instead of calling this a match pattern, I guess I'll call this a like match any. Right? Because basically what it says is if there's a 1 in the 2-bit lane that corresponds to the thing you're checking, you match anything. And off you go. Right? If they're all 0s, then you have to match exactly. And if any of them are 1s, then you don't have to match that lane, and you're still considered a match. Now, I think... I think that's mostly it. And so there's a couple things we have to care about here sort of a little bit, I guess. Which is this. The way that we were doing this before, we need to handle the wrapping part correctly. So we do want to like just double check that we're gonna map the like facing directions correctly and stuff like that. So we're gonna have to take a look at that eventually as well. But you know we'll get to that. We'll cross that bridge. We'll burn that bridge when we come to it. So now the only thing that I think is implied here is that this is now like an asset ID effectively, right? And I don't know if we have asset IDs as a thing. We don't. So anyway, so that's what we need there. And if these are U32s, then, oops, that shouldn't be a pointer. Then everything should just work. And when we loop through these, it should all be fine, right? And off we go. This is not called asset. It's called check. That is supposed to be a C value. And there we go. All right. So in theory, that's all we needed to do, right? And now, yeah, like, so we have a couple different things here that I'm not sure about. So it looks like what we did here is we plow an asset category in, and then I mean, I don't know. Like here you can see who knows what we're doing, right? Like we're just munging these together into a value that preserves as many bits as we thought that we would need, right? And you know, that's all fine. This semicolon, you know, I don't know what that's doing there because you don't put a semicolon there, but apparently that's where that is. And if I look at this, right, that if the indentation was working, which it's not, and I don't know why, then we should end up, right, with that being the correct set of things. All right. So now what, right? Like, what do we do now? So now I think we just need, like, that function we were just looking at, right? Like get tag hash. So I think all we really need to do now is like this code just kind of gets simplified quite a bit, I think. So I don't really know why it says smoke for a particle that's fire system, probably because we were just screwing around with it, but whatever. So we are going to say like, we'll just call this tags for now. So we're just going to say like get tag hash here, right? And what we want to do is we want to say that this is particle smoke, because that's what we were doing before. And then we just need asset particle as the category. And then I think instead of get best match bitmap from, you can see how much smaller and simpler this code gets. We just say, give me, you know, this thing, right? And I think the problem we would have here is just that, like, we probably want multiple of these. So, you know, presumably you would want to get more than just one bitmap, but that's a limitation of the particle system that we haven't actually done anything with. So, you know, we don't really have to care about that particularly much. Now, for these, we don't want to have to always pass in all of the tags. So I'm guessing that what we probably want to do is just say like, all right, for each of the asset tag IDs that we have here, we'll just assume that they're none unless somebody says otherwise, right? So just to read that a little clearer there. So we assume that there always has to be an asset category. Maybe we should say there's always at least the first one there. But I don't know. And then we just do get bitmap. Is it just called get bitmap? No. What's it called? Get best bitmap. Get best match bitmap from. Yeah. And then for the asset matching here, what we would say, I think, is just like, look, if you don't have a match vector, then you don't, right? Because you wouldn't need to have one. If you just pass in all zeros, then if there's basically a default value, that's what you'll get, right? I think that would be pretty much it. So at that point, now we just have to go clean up the code that was doing other stuff. And I think because we sort of, I don't know, maybe we did a good job. I don't want to say that offhand because maybe we didn't. But I feel like we ended up doing a thing that's like really direct and straightforward, very simple, would be quite fast, and as an extra added benefit, is super easy to port. So in this case, I think when you say get best match sound from, like in this case, you can even just collapse this whole thing like down to like just this one line, right? Because all it was a tag bloop here. So all you would say is get tag hash. Tag hash. There you go. Is get tag hash with the two things that you were passing before, and then you delete all this code, right? And I think that's it. Like that's all there is to it, right? So that seems really good. And so all we now have to do is port all that code that was doing that into something simpler that's nice and efficient and clean. We don't have to worry about all the garbage we were doing before, which seems really good. Now, here's the part where we care about this little snippet of code. So in here, right, we want to prepare this match vector, and we want the match vector to, like, make some sense. And so what we have to do is figure out what are the things that are actually going to go into this match vector, and the problem that we have here is, like, I have absolutely no idea how we want this thing laid out. And so what we probably want to do is make a wild guess about, like, what this match vector is going to have in it. And probably it's going to be something like, I have no idea what it's going to be like. We know a few things that we have, right? So maybe we just start by talking about what those are. So maybe we say asset match vector elements, and we just say like match element, and we've just got these 4 here, right? And it's similarly like, we can just say like, oh, well, there's however many there are, right? So we could just say, well, what are these things? So like, what are the different values that we're actually going to talk about having in here? And we knew that facing direction is one that we look up on. We know that variant is one that we look up on. And I don't actually know if there's any other things, at least at the moment, that we actually, want in there. Because we don't have a lot of other parametric stuff. So it may be that, like, that's it for now, right? And so it's not even like, and we could try to always make sure this is like reserved at the right size or something, and I don't know what we want to do there, but like we could just say that, right? And another thing that we could do here is we could say, if we wanted to, that there's like less room, because we don't have, like, we know we're not going to have 4 billion variants of something, right? That's not going to happen. We don't have the art budget for that. Red Dead Redemption probably has 4 billion assets in it, but we're not gonna. So anyway. What I was trying to say is I would like to make it so that this is as like self-explanatory as possible and as simple as possible, because this is the one part of the system that doesn't get handled by the hash, right? We have to check individual elements to make sure to see which one we've got. And so, it's the one part that we can't, that has to be sort of like a slower traversal of some kind, right? And we can still try to make sure that the traversal isn't too slow, but it's not like the tags, which are exact matches. So the exact matches can just go directly through the hash table, and we can know that they'll be like very, very efficient. So, we'll see. All right, so moving along from there, if we go ahead and assume that we're just going to use facing direction and variance, then I don't actually know if we care about variant much in here, but if we take a look at the match vector, which is going to be this, then really all we have to do is fill in that one facing direction value. And the problem that we're going to have here is that the facing direction, whatever that may be, and oops, I forgot what it was. So it's this right here. That's going to be a floating point value, and we need to like bucket that floating point value in there somehow, right? And we want it to be periodic. So the facing direction itself, like, I don't know where that's actually getting computed. So, yeah, like, it's just an angle, right? It's just an angle from 0 to 2 pi, probably, which is, you know, dumb, but so if we imagine that we want this thing to map into a facing direction, the facing direction should be between 0 and 4, where 0 is what the match you would get when the thing is, you know, facing right. My assumption is that we could just do something, at least for the time being here, where we just say, all right, well, so really what we're talking about here is that we want to like take the facing direction and we want to like remove from the facing direction probably like pi 32 over 4. So like, right, we want to take a quarter of the, so if we imagine the circle, right, we want to take a quarter of a circle, not a quarter of a circle, a eighth of a circle, and move back so that we're talking about the quarter of a circle that would be encompassed there. So if you imagine like the facing direction is 0 to 0.25, that would map to 0. But so would yeah, so I guess, yeah, So I guess what you really would do is something like this. Is that right? So you would effectively say, look, I want to divide the facing direction by a quarter pi. So, you know, if we imagined this constant here, right, like called quarter pi, we would multiply this by quarter pi, and then we would round it to a real number, right? I mean, to an integer. And so if we did this, we would now have like which quarter, which octant of the circle you were in. So 0 is the first octant, 1, 2, 3, 4, 5, 6, 7. And now all we really need to do is we need to make sure that 7 and 0 both map to 0, 1 and 2 map to 1, and et cetera, right? So, yeah, like, I think we just take this. We take it's not particularly pretty. I'm going to do a little mapping here. So here's what we would want to happen. Again, what is up with the indentation? Like, so indentation in four-quarter used to work, and now it just doesn't at all. Is that some aspect of four-quarter flurry, or did the indentation break at some point? Is the indentation broke because virtual white space is disabled? But indentation's supposed to work anyway, right? Like, indentation's supposed to work whether or not virtual white space is on or not, right? Like, it's supposed to be able to indent the code. So I'm not sure. Yeah, I don't know what to do about it. Like, indentation's like really severely broken as far as I can tell. But I'm not sure. We may need Alan to like fix it because it used to work. That's the thing. Like, so it broke, I guess, or something, and probably needs to be fixed. So that should be fixed because it used to work. You know what I'm saying? Like, it regressed. I mean, at the very least, you need to be able to have a comment. Like, that's not gonna work, right? Like, that's not good. And that used to work just fine. So. Okay, that's even weirder. What the heck? All right. Well, I don't know what to make of it. So anyway, what I wanted to do here was just say, look, let's try and say what we want to have happen here. All right. So these are what we would get. If we divide it into quadrants, we're going to get 0 to 7. And we want our mapping to look like this. Right? So we want to say, after we've divided out, we want to go ahead and take 0 and map it to 0. We want 1 and 2 to map to 1. We want 3 and 4 to map to 2. We want 5 and 6 to map to 3, and so on. Yeah. And so if you imagine what's going to happen here, we can pretty easily accomplish the middle part, because that is just -1, subtract 1, divide by 2. Right? And that gives you what you want. Or I should say add 1 and divide by 2, right? So if you imagine 1 plus 1 divided by 2 equals 1, right? And, well, I should... Right, so if you imagine that our equation here is just going to be, you take the thing, you add 1, you divide by 2, then that's going to equal what we want, right? And the same thing would be true here. 2 plus 1 divided by 2 is also equal to 1, because remember, we're integers here, so we truncate. 3 plus 1 divided by 2 is actually equal to 2, and so on. So we know that we can produce the middle part of the table by just doing this value here. And in theory, this part, the first part, where we do 0 plus 1 divided by 2, that will also produce 0, because, again, because of truncation, we haven't quite hit 2 yet. So our only real problem is that Mr. 7 down here, so 7 plus 1 divided by 2, is actually going to be equal to 8. So I think all we really have to do is just handle that one case, and we should be able to do that by modding by 8. And if we mod by 8, that should be able to turn into just a mask. Because modding by 8 is the same as just masking off the upper bits, right? So I think we can produce an extremely efficient way to produce this. We just do one floating point multiply. To produce the facing direction index. And all we have to do here is say, like, okay, it's just going to be equal to the facing direction index plus 1 divided by 2, right? Which, as we know, would just be a shift down, right? So we just shift it down once, and then we and off the part we don't care about. So we know that we want the bottom 3 bits, but anything higher than that we don't want, right? So we want bit 1 and bit 2 and bit 4, right? So we just want that. So I think this is a pretty efficient way of producing the actual index value we actually wanted, right? Which is a number between 0 and 3 that tells us which of the facing direction sprites to pick out. So I'm pretty sure that that's, you know, going to be a nice efficient way to do that, right? You can see that it's pretty straightforward. It's literally just a constant multiply here. And that was wrong. This should have been invert that, right? This is inv quarter pi. So we do the divide. That puts us into integer space. We apply the magic formula here, and then we should effectively have, and I guess I don't even need to put that in there. I could just put it there, right? We have the value that we actually wanted, right? And I don't know if there's really anything else. That may just be it. So, okay. So hopefully that is just it, and we can go from there. It seems like there's some complaints here. Oh, that's probably because this has to be U16. So let me just make this the same way that it was before real quick. So there's facing dir index equals facing dir index. And I don't know if this is smart enough to, yeah. So, you know, we just anded this with 07, so, like, it should know that that's totally legal, but, yeah, whatever. Cannot convert argument 2. Well, you know what? You've got a point there. So this we probably typed in before we had this as a type. So it probably should look like that. Is asset tag hash, like, not defined yet because of the, you know, the miracle of C? So this is in the entity file, and I guess does the asset system not come before that? Is that the main problem? So, I mean, there's asset.h and there's the entities. So I guess yeah, the answer is it doesn't. So I guess what I would have to do there is just say, well, you know, maybe we put that up in file formats. And yeah, I don't know if that's sensible or not. Might not be. But you know, I could see this being something that we want to have in the file format section because we may want to start storing these. I'm not sure. We may or may not. But we can put those there for now. Again, things that you only care about because C++ never bothered to do the work of actually letting you compile your code without having to pre-declare everything. Yeah. So anyway, taking a look at what happens here, these are all just tag hash things again. So this is, again, really probably pretty straightforward. So all we would really need to update here is the part with the where we actually pick the variant. And I guess the thing with the variants is we don't really know how many variants there are of a thing. So what we were doing here before, is we let the automatic matching system like just kind of find which we let the automatic matching just use the range from 0 to 1 to pick variants out. And I don't know how I feel about that one way or the other, to be completely honest with you. You know, one thing I would suggest is that, like, probably it seems like a good thing to support because you want to be able to just dump more, like, grass sprites in and then they get distributed out. So it seems like something we would want to support. If we wanted to support it, it's not particularly hard. What we would have to do, though, is we'd have to have some kind of a mapping piece of information for the assets that they use when you look at the variant field. You'd have to do a masking to always make sure that the tag that you're matching against is in the range of the assets that were actually recorded. And I guess I just don't have a strong opinion about that, and I don't really know. I don't really know what I want to do there. My intuition kind of says, like, hey, that's, like, why make that system more complicated for no real reason? When you could just say, look, when you're actually talking about what the game does, it's always going to just be in a situation, it's always just going to be in a state where you do know how many there are, because you know how many art assets you're going to put into the thing. So you could just always say, well, you know, there's this many variants. You know, this is how many variants things get for things like grass and smoke and whatever. But on the other hand, I'm like, well, it would be nice to basically say, like, look, just record how many of the thing there were. And then, yeah, but if you can't merge assets anyway, because you have to be able to distribute them along the uniform, like, because it's picking a random unilateral here, even the old system couldn't have merged assets properly because you would have had to redistribute things along the random unilateral, which would require you to reprocess the art assets anyway. So at some point you needed to know how many there were, and so what you could do is just store how many there were. Rather than complicate the matching system, what you would want to do is just be able to look it up here, right? So you want to be able to just look up here, like, how many of this thing are there? So tell me, and then I will, you know, I will pick a variant inside that range, right? I assume. My assumption, right? So, yeah, I guess. So, yeah, I don't know. That's a tough one. I don't think there's a good answer to that exactly, but I don't know. Also, you know what I was just realizing? This is probably wrong. Because we already did the divide by 2. So actually, we really only need to mask off. We only really need to keep the bottom 2 bits, right? And then we should be fine. So I don't know what to do with this. So the rest of this code is trivial to port, right? So if we assume that we have the asset tag hash here, then all we really need to do is for each one of the things in the spec type here, we would just do like tag hash value, tag hash equals get tag hash, and we'd just pass the tags that we were talking about, right? So in these cases too, like where we have like cover type, I mean, we could just pass the tags instead. That may not be a good idea because we might want to do more complex things here. So I won't pull it out just yet, but it's entirely possible that we can, like, now that we've got this, we can simplify that part rather dramatically, right? Like, it could compress down to very little because we could just have those be stored in there. So I don't know what size being 0 or 1 here, that sounds like that wants to be another parameter, right? So that would be like the match vector dot size, assuming that size is a thing we actually want. Oops, sorry. What did we end up calling this? Match element. So assuming we actually want this, like, yeah, I don't know what these should be, but we're basically saying, like, okay, so there's size is a thing, I guess. And these would be smaller. Now, I don't know if that's the way you would really want to do this, because you may just want to have 2 different tags, like large and small. So you just tag cover large and tag cover small. So I'm not sure that the size thing really makes a whole lot of sense there, actually. So I don't know. So it's hard to say. And I don't know. I don't really know what we would want to do there. That's a tough call. We'll have to think about that. So assuming that we go ahead and do the tag hash thing, then in here we know that these are always particles. So that can just be assumed. And then we need the asset match vector here. And that should just work as well. And the rest of this code should be fine. This is the only part that's a problem. The match element variant here. This would be like a random choice, essentially, and it would be in some value that we don't know what it is, right? So what we need is like max, you know, like the variant count for this thing. So you'd almost need like a get variant count for a particular asset category. So like for this particular tag hash, what is the variant count? And that would just give you back like the value that you need to do the random choice in. Right? So, I mean, I think it's good. Like, I just think, yeah, we probably just want to... I mean, that's probably just what we want to do. Like, we probably just want to have this be an element of the asset system where, like, when we process the assets, we remember how many there were. And off we go. I guess. So anyway, that does seem reasonable, and we could just assume that that's what we're going to do, and then this is the only thing that really is, you know, a problem here. This is going to be a U16, and so it would really only be this that would be the problem. As far as size is concerned, like, I don't know that we really want that in there. And so I want to look and see in the sources, like, so if I look at the base game HHT, right, and we go looking for, like, what's happening with the size stuff. So here you can see, like, there's, like, a size parameter, and so I just don't know. I just don't know that it makes sense to, like, have that. Like, why not just have large as a specifier, right? So let's take a look at I mean, presumably the particles. Yeah. So you can see, like, we've got particles. There's, like, 0 and 1 and stuff. So I would say, like, that should probably just be another tag. So I don't think we actually want to actually use a match element for that, because I don't know that we would get much out of it. Like, what's the point, right? Like, we're not going to have, like, 30 different sizes of something. So there might, if we want to say that there's a large one of these and a small one of this, then that seems like something we would do. But I don't know that we need, like, some other thing. That's just my, I don't know. It's just my intuition. It may be wrong. But, like, so if we, and so in here, right, if we just imagine, instead of saying match font size equals 1, right, we just said tag large. And here we could say tag small, but really, like, maybe that's just whatever it is, right? So something like that seems better to me. Oh, is this what was happening? Maybe this is what's happening with the indentation code. Is that what's happening? I don't know. Maybe the problem is the key bindings, not forcoder. I'm really confused. So let's try this out here. I mean, the auto indent is obviously busted. No, it's just broken. I don't know. All right. So yeah. So I think that's all right, and we just would need that tag. So in the tags themselves, like, size would have to go away, and we would have to just have large. So, like, particles grasso 1 would not have a thing. And this would have a tag that was, like, large, right? And this would not, and this would not either. I don't know what that is about. And this would have it, and this would not, and this would, right? Yeah. And so a lot of this stuff, like, yeah, with these scenery tree, like these tag nonsenses, right? We would just change the way this would work a little bit. So in here, this is saying, like, it doesn't have winter, dark, or fall, I guess. It just is damaged, but now we don't need that anymore, right? Because the way the tag system would work is it will jump, like, directly to that thing. So I'm pretty sure we don't need this matching nonsense, because I think this was just to work around the system before was kind of just being broken. So I think you would just say that, right? You don't need to specify all the things that you're not. You can just specify the things that you are, and it should go directly there, right? That's my assumption. We'll see. That may be totally false, right? But hopefully it's actually okay. I think that's everything that we needed. And so we just now need in the file formats themselves, we need one of those tag large things. So like, you know, just add that in. And there should be a way to presumably add this pretty simply. Yep. And off we go. So I think that would work. And this is the only thing that we don't know. So for right now, rather than try to shoehorn that in here, I think what I'd probably do is just say, all right, so, you know, maybe at the moment there's going to be like a thing that says that the variant count is like always. By the way, that situation right there, just this is why I think it should go in the opposite. It should go like here, right? Like I feel like it should always go, or what you could do is test where the cursor is and put it at the top if you're at the bottom, right? I think it should always be like out of the way. Sort of a separate issue. Anyway, so yeah. If we take a look at the asset system query here, where we have game assets, we're just going to assume that in the future, somehow, right, we will be able to look up an asset tag hash, and we'll be able to get a way of, you know, reading some measure of how many variants there are. And we'll just say, for now, we're just going to say, hey, there's, you know, I don't know, there's 8. And we'll just say to do, need to actually remember and store the total number of assets, variants, you know? So I think that's probably all good. And now what we need to do is just change any of the plumbing that doesn't, you know, align with that, right? So in here where we have asset basic category, and we've got the asset category listed here, this is actually not going to provide that anymore. It's going to provide the asset tag hash, right? And that's going to be nice because that will allow us to do a bunch of stuff that we weren't able to do before. So that's going to be good. It's just going to be easier for us to specify art assets, which is the whole the whole point here, even though this will also speed up the asset matching dramatically. It also just is easier to use, which is the main reason we actually cared about it. It was not actually the speed, because we weren't actually trying to optimize it at this particular time. It just so happens this will also optimize it. All right, so we're now in the cutscene layer, and so looking at this, I feel like pretty much shot index is probably something that should just be collapsed down to like variant or something, right? Like, I don't think we, for any particular reason, need the shot index to be an actual thing, right? Because that could just be the variant. So here's the way we've got this set up. And you can basically see, like, we've got two things here. We've got shot index and layer index. And yeah, I'm not sure we actually care about that. Now we could potentially say that we care about some aspect of it. So layering, for example, might be something we want. to have its own value. I guess I don't know what I would say about that. Like I could, like, if somebody made the argument that asset match vector should have layering as one of the parameters, like, I could believe that. And so maybe you say, like, well, the shot index is the variant, you know, and the layer index is the other one. But really, when we look at this, that to me just doesn't seem like logical. So, you know, I would think that instead what you would do is rather than having these be matched, because these are direct lookup, like, there's no ambiguity. These are cutscenes. They have to be exactly the thing that they are. You really would rather those things just get plowed in to the tag hash itself, right? So I feel like what you would want to do is really just have those be actual tags. I mean, it's a little bit annoying. It's annoying from the standpoint of the person who actually has to sit here and do this garbage. Like, so in the file format, like, if you actually have to sit here and do this, like, that definitely sucked, right? But at the same time, it's like, well, it only really kind of sucks because C sucks, or C++ sucks, I should say. It is actually the right thing for the system because it allows you to just wrap those tags directly up and look them up instantaneously. So it's what you want, and the fact that C makes it annoying to do is not necessarily the reason not to do it. Right? So if you just assumed that you had some ranges reserved, you could write some code that would do this as well, like, more efficiently, where you just said, like, okay, we're going to reserve this range, and then when we see, like, a parenthetical with one of these things in it, I'm probably not going to bother doing that because I think this is fine the way it is, probably. So we can probably just go ahead and, you know, do this and call it a day, right? So I would say let's just do it that way, because I think that, I don't know what that's about, but that is yes, my phone ringtone is the Monkey Island theme song. I mean, clearly that's the right decision. I don't think anyone, you know, could argue with it. Does anyone know what Ron Gilbert's doing these days? I'm gonna send Ron Gilbert an email. I think on a previous stream, like, I don't know, a couple streams ago, I think I said that I thought that Ron Gilbert was one of the best programmers, like, in the history of gaming. And I was thinking about that the other day, and I think that's probably just true. Because one of the interesting things, so here's something. Let me go ahead and just lay this out for you. So there's different ways, there are different skills that great programmers need to have, or can have, right? Because when you're great, like, it's the same as being a great athlete. Like, I mean, everyone knows what happens when, like, you know, Michael Jordan went to play baseball or whatever. Like, he wasn't the best baseball player, right? But he was certainly one of the best basketball players, right? So, you know, when you talk about programmer is sort of like saying athlete. There's different disciplines inside it. And, you know, if you're being a great programmer does not mean being great at everything. It means that you were great at something, usually, because nobody's great at everything. Like, there's no programmer who's great at everything. That doesn't exist. You know, so some programmers get more credit than others for various things, because a lot of times the emphasis, when you talk about people who are famous for doing programming things, the emphasis is on things that are not necessarily, they don't necessarily line up in any particular way with the actual, like, with how good you were at the thing, right? I mean, you could certainly start with certain things, like, you know, maybe like you could say that somebody, I don't know, like Mark Zuckerberg is a famous programmer in a sense, right? Probably a pretty lousy programmer, right? Because, like, what you're famous for has really very little to do with whether the programming was any good. Like, and from everything you can kind of see about Facebook, the programming, especially back then, but even today, is not good, right? So we wouldn't say, you wouldn't imagine that the actual programming skills are particularly good there, but you're famous for some other thing, right? Because the thing you built became famous or something like that, right? So there's some of that, but then there's also programmers who are famous for actually being good, and like an example of that would be like John Carmack or Mike Abrash or somebody who's like, you know, their names are known pretty well because they actually did do like programming things that were important to people, and their like skills in programming were actually why they were famous in a lot of ways. And so that happens too. But I would say that one of the like least likely things you will to be famous for in programming is if you are a brilliant architect. So if the thing that you're best at in programming is figuring out what to do when and how to do it, right? Like how it should be organized, and less about coming up with some specific fancy algorithm, then I think you oftentimes maybe don't get the credit you deserve. And I think you especially deserve some credit because that skill seems to be incredibly rare. And like when you look at things like, yeah, if you go back to like programs that are famous like Facebook or something, and you look at how incredibly terrible their architecture is on all levels, like from the network architecture to the server data center architecture to the like code itself, the architecture is terrible. Like it's just absolutely horrible, right? From start to finish. And they've gone through like billions of them, right? And they keep updating these things, and they're always awful, and they continue to be awful, and there's just no brilliance there, right? And that's true of like a lot of things are architected. So my argument for Ron Gilbert being very underrated as one of the best programmers, I think, in the history of gaming is, if you look at his track record for game architecture, it is absolutely insane just how good it is. So he did basically Scum as an architecture for literally from the C64 through to like modern CD-ROM based, like, and then hard drive based large asset systems, basically continuously. So that same system, you know, with being revised over time, ran everything from Maniac Mansion all the way to like, you know, Putt Putt Saves the Zoo and stuff, right? And I feel like the level of like the degree of like level-headed decision making that has to happen to be able to like make graphic adventures for an unbroken period of like 20 years, and have it ship so many titles so reliably across so many platforms, it's just kind of ridiculous, right? So I feel like, you know, that's that's one of those situations where I feel like, we don't have metrics for saying who is and isn't a great programmer, and it's not, like when we want to talk about like athletics, you can see why it's so much easier because there's all these obvious statistics that people gather, right? Like, we know how many times, Michael Jordan scored a basket and under what conditions and all these other sorts of things. And so pointing to a particular set of statistics is a good way to bolster an argument that somebody is great at something. And so I do think that, we suffer in programming because it's very hard to point to anything that's a concrete statistic. And the success of a piece of software has very little to do with how well it was made, because a lot of times something can be successful simply because you were at the right place at the right time, or you had like a good monopoly advantage in some way, or other sorts of things. So it's really hard to point to things like, well, this software succeeded because lots of software succeeds doesn't mean that the programming was any good. And so, it's really difficult to assess those things. And so I feel like because we don't really have any metrics, it's hard to talk about things, especially things like architecture, that are very diffuse, very difficult, and very poorly understood. And so I feel like you get someone like Ron Gilbert, who maybe hasn't ever developed a flashy 3D graphics routine or something like that. That's kind of the more obvious thing that people get credit for. But when you look at, I think, his track record of really just delivering incredibly high quality stuff from the architecture side way earlier than anyone else was able to as well, and to have that architecture hold up over time and be able to like more or less seamlessly go from being something that ran the first real point and click adventure on a C64 to something that ran, like a modern, like fully voice acted CD-ROM streaming system. I just feel like that's one of those things that I don't know anyone else who did that. Like I can't point to another example of such a long, unbroken architectural track record. And to be honest, I think if graphic adventures weren't kind of crappy from a game standpoint, like, we kind of, the game design of graphic adventures failed to evolve. And so they kind of died out in a way. If that hadn't happened, that track record might just have kept going, right? Like, the reason that Ron stopped making those was not because his architecture fell apart or because he couldn't figure out how to make like modern technological versions of them. It was because the market didn't want that type of game anymore, right? And so in a way, you might say that the architecture itself like literally never failed. Like, he never actually got to a point where his architecture skills didn't continue to take him forward. It was simply a fact that the market didn't want this thing anymore. That's the only reason we didn't have an even longer unbroken period of like, that system delivering. So I think that's my argument there, and I'm sticking to it. So I feel like, I would say like Ron Gilbert's probably the most underrated programmer in game history, because like I feel like he was incredibly good, just incredibly good, and doesn't really get the credit he deserves, in my opinion. I mean, he does get credit, so it's not like he's like, it's not like no one knows who Ron Gilbert is. Like, I mean, he has a massive following and all that stuff, but it's like, I just don't feel like people give him the level of credit that he deserves. So he does get credit, but I think he should get even more. Let's put it that way. Another way to say it is, I think he gets credit more as a game designer, right? In other words, like, I think people credit him more because they like the games he designed, which is great. But I feel like he deserves more credit as an architect, and I don't feel like he gets that credit, because I feel like he did some incredibly pioneering work and demonstrated throughout its history just how brilliant and resilient that it was, right? And how smoothly it was extended, and how he never made those wrong decisions, right? Like he didn't ever ship a dud on the engine side, like, and that's, yeah, it's pretty cool. So, all right. I think we're almost out of time, but let's see what we were doing here. Oh, this is just again another straightforward thing. So what we want to do here is just be able to pick out which shots we're doing. Instead of shot index now, we could actually just make this be a tag. But since these actually go in order, I think I'm just going to do this mathematically because we can. So I think what we want to do is say, okay, so there's an asset tag hash here, and so we're going to go ahead and pull that out. And we want to say, oops, get tag hash. We want to say here, like, where's the thing that actually, so here's what we want, right? So what we want to be able to do is we want to be able to say, like, tag layer index, you know, and then we want to do like a plus here, right? So we want to do like layer index plus the layer index value. I think these will be off by 1. So, I mean, I think we'd have to do this because it seems like, well, actually, I guess I don't know. How do we line these up? So, anyway, it looks like, where is the layer index value? So here it looks like we like pre-subtracted it, right? So if we just don't do that, so if we just go back to what we were doing before, before we introduced that, 1 offset, then this is actually just correct. So if we just assume that it's like the offset of the layer index, then that's what we would want. And then for the shot index presumably also like has to be adjusted to not be up by off by 1. In this case, intro shot, and we just have these things here. This actually, I guess, is fairly straightforward because actually this part here, where we create the thing that would normally have the asset information in it, seems like we should just be able to change this into like that. You know what I'm saying? Like, we should just be able to paste the tag value in there. So in layered scene, we could probably replace shot index with like a tag. I don't know what's the actual tag ID. So we should be able to replace that with just which shot tag is it, right? And so in here, I would say like that shot tag is just gonna come from this. And then the layer comes after it. And so here, I just had a really interesting thought. Yeah, this is okay. Bear with me here. So one of the things that will happen currently with our tag matching is that if the order of the tags is different, then you wouldn't match, right? So if I said this shot with this layer, it wouldn't match something that was recorded with this layer and this shot. So my question is, should we fix that? And I guess I'm gonna go with no, because it's less efficient to do so because of the fact that we don't have enough things to do. But what I would point out is if we wanted to, we actually could make that work. So the way we would do it is we would AES deck each individual tag into its own 32-bit hash, and then we just XOR them together. Because XOR is not order dependent. Like if you XOR things together, you know, you'll get the same result either way, if I'm not mistaken about that, right? So if I just XOR this, you know, if I XOR if I XOR A and B and I switch them around and XOR B to A, I will get the same result regardless, right? So that should mean that we could put the tags in any order and then they'd match. I don't really want to do that though, because we can AES deck more efficiently if we don't have to do that. You know what I'm saying? So I think I won't, but I just wanted to point out that that's an interesting idea. Like, we could do something like that if we wanted to. So I don't know which kind of asset we're getting here. I think it's a plate asset, probably. It looks like scene asset type is actually what we're trying to get. So I guess we'll just keep doing that. You know, why mess with success? We don't have a weight a match vector here of any kind, really. So that'll just kind of stay. And yeah, I think that's it. Yeah. So I think that's all we need. So the shot tag should be correct. This asset tag ID part, this has to be cast here because we don't have a way of, yeah, we can't actually do those offsets properly, but this is just tag none, right? And this is, what is this? Title screen, shot index. Oh, so this is just the same thing for the title screen as opposed to the cutscenes. So again, get tag hash solves the problem. You can just see, like, this code was just terrible before, right? I mean, not terrible from any, we weren't measuring anything. It would have been very slow as well, but I just mean from just having to, like, deal with it. Like, you can see what a pain in the butt this was. And so now that we know what we actually need, we're just able to simplify that quite a bit, right? And furthermore, like the shot index, layer index thing, I don't actually know that we care about that here because I don't know, like, what, there's only one title screen, so, like, I don't know what this is about. Like, I don't know why you need shot index 1, layer index 1, but, you know, I mean, okay, like, you know, if we want to leave that on, we can. Maybe we want to put more stuff in there later, I don't know. So, again, nice and clean here. And you could even do that in one call if you want. So you could just put that, right? I mean, not in one call, but in one line by just putting it in there. I didn't see any point in doing that, but you could have. All right. So in this case, yeah, same thing. Like, this just gets a lot cleaner. Like, it's just a lot more pleasant because now it's like, look at how much nicer that is, right? Just as code, it's just a lot easier to, to deal with the simple case, and you know, it just makes it much more pleasant, right? What is this complaining about? Cannot convert argument to. Oh. Oops. Does the font do something different? It's just assets and asset tag hash, right? What is font type debug? I guess there's the part I don't know. Oops. This is just going horribly wrong. So one of the problems that I have is I think I need to fix my key bindings. I should write this down. J should work everywhere. So for some reason I had the J turned off in other buffers. That's just a bad idea. I obviously want it to work everywhere. So yeah, so something about this situation is a problem. This get tag hash, probably because the font type debug thing is not Yeah, so I don't know what that's supposed to be about. I mean, if I feel like all we need to do is just I don't know why font type is like a thing. I don't know what the point of this is. Probably because we were trying to use the old matching system. So I'm not sure, like, that we probably just want to, like, clean up. If we look into fonts, so we've got some fonts here, right? And you can see that we did a tag, for some reason, font type 10. Like, what? Okay. I don't know what the point of that is, but that's the way we did it. And so I think we just want to get rid of that garbage completely. So instead of that, what we would want here is like, this is our debug font, right? Or something, right? And then we've got the other font, which is this one. And wait, how are they both the same type of font? Wait, if they're both debug fonts, then which one do you get when you ask for one? What the heck? That doesn't really make any sense, does it? I'm sure there's, if we go back and look at the stream, if we go back to the instant replay, we'll be able to figure that out, but yeah, I mean, so which one do we use? Is it just because we picked, like we randomly were picking between them? So it looks like we only include Liberation Mono is the answer. So yeah, I guess we did. So, all right, well, guess what? The tag is debug font. All right. So now, I argue, what we want to do is just say that this is the debug font. And then in the file formats, we would just, there's no more font type. That's not a thing. And then we just have, like, hey, it's the debug font. Right? And that's what we actually wanted. And eventually we'll presumably have a game font, but we just don't have one right now. All right. Looks like add piece was not actually defined anywhere because presumably we've got in here the old way of doing things with the asset tag. Oops, no. Well, where is that defined then? That's weird because, either way, this is not correct anymore. That would still be tag hash. And I guess I don't know where the add piece definition is. Let's find out. Because it must be wrong somewhere. Here it is. So this just needs to be replaced, like so. And there we go. All right. So I think this allows us to fix all the problems we were having before too about like not being able to pick who was who. So like when we add the pieces for different people, we can now say like, oh, which of the characters were you and whatever, because the pieces themselves, and they can mix and match, right? So a piece could have a specific thing associated with it. So I think this is just like get tag hash, right? And the only thing we need to do is specify like which one it is. So I'm pretty sure it's just like tag hero, right? But I just want to check. So inside Handmade, inside base game. So if we look at like body hero, right? It's got orphan, hero are the tags. And so we would just put orphan and hero in there, I think. And that would be that, right? And then it would use the facing direction to pick it out. So I want to go see, like, because we're going to have to do some reorganization here, obviously. I want to go see like what that actually looks like. But so in here, if we take a look at body hero, right? So the facing direction would pick, and then the expression axis there, we don't care about. But I'm pretty sure that works for everybody. Yeah. So it's just like facing direction tells you the up, down. And then there's other garbage over here that we don't have to worry about because we don't actually use that right now. So this is all going to be like body orphan hero or whatever there. And so one interesting thing about this is that it does kind of, it sort of wants in a way the ability to change the asset type of a tag hash that you already have. So you would want potentially to do something like this as just a sort of a service. So if in here we had something like base tags. So here we would say, okay, the base tags is just like, you know, asset none because we don't care about that. But then like tag orphan, tag hero, right? And why we would now have tag orphan in the first place, I don't know, because we don't really care about that. But maybe, you know, I'm not going to delete that at the moment. But anyway, so now what would be nice is if we could just do this, right? So effectively, there's just another version of, oops, that's going to kill me. I got to fix that. There's just going to be another version of get tag hash here where instead of passing any of those other elements of it, you actually pass an existing hash. So that has all the tags in it. And then this just merges them together. So it basically takes the category that you pass in and ORs it with the tags that you actually have, like so, and produces the result that way. Now, the only hitch here is that bottom piece, right, is an 8-bit value, and we want to make sure that it's not, like, adulterated. So we want to make sure... Oh, wow, I can't type tilde for some reason. That's weird. So shift tilde doesn't work? That's a huge problem. Shift tilde doesn't work. All right. That's an issue. Not sure how we fix that. I guess I'll talk to Alan about it. So, well, you know what? No, I do know how we fix that. We can just bind shift tilde to insert character. That should work fine. Anyway, so yeah, I just need to borrow a tilde from somebody else, I guess. Of course, how to find one, I don't know. But I need to be able to not this. Because I want to be able to say, like, look, the bottom 8 bits, right, we want to make sure are clear when we OR this in, because we don't want the category to get, you know, mussed up from it, right? So that seems fine, and if we had a tilde, well, we'd just do that, but we don't. So off we go. So let's go ahead and see if we can fix this. So in the binding file, so that would be in apps for coder bindings. So the tilde, so it's tick, right? And so I don't know like exactly what I would bind here per se. I guess it's like write text or something. But what I would need to do is pass like shift here and just say like if somebody does hit it with the shift key, then they're supposed to be able to insert that actual character, right? Now we will need something to bind it to. And I don't know what that is. We need like insert text, right? And I don't know what is that function. It's like write text. There is a function for it. I just don't remember what it was. Thought we used it in here, but I guess we got rid of the places that we actually needed it because there were existing things for it, and so it never actually happened, which is too bad. So yeah, right. So it might be that like write text and auto indent. No, but that's the bind text input. So I don't know. Write text input, Ryan says. So all right. So let's try write text input because Ryan says so. Let's try that. And we'll see. I just saved that, so yes. All right. So let's take a look and see if I can type a tilde now. I can't. Still. So I don't know. I don't know how do we type a tilde, folks? Because it's bound, yeah, I don't know, is there some other magic to it? I'm assuming that that's what that looks like. I guess we'll just have to talk to Alan. All right, so until next time, I guess we'll just say like insert tilde here, and we'll go from there. Yeah. I could cut and paste one if I could find one, but of course I can't search for it either, probably, because it wouldn't let me type it into the search, right? Otherwise, I would have just searched for one. So I have to like just hope that there's a not. Oh, so maybe in like the intrinsics would have one because we would have had to have knotted something in here probably. It's the kind of place you would knot something. Or maybe in the math stuff. There it is. So we could probably just smoosh that in there. There we go. All right. All right. So I think that's it, right? And so now we would just have to kind of like to modify some of these. Did we not save this? Maybe we didn't save this. Didn't we already do this particular one, though? All right. We're going to do this next time because I don't really want to do this at the end of this. But if you look, like, basically what we're looking at here is all we really have left to do is just map the pieces that we've added to all of our, you know, to the in the level gen. We just have to map those to the right thing, you know, to the new system. That seems pretty straightforward. So we'll just leave it at that. And maybe after the stream here, I'll try to coordinate with Ryan. I owe him to send the changes back. And I do have to figure out a way to fix that tilde, so that might require Alan, because it doesn't look like that has anything to do with Ryan's code. That's just for coder mispicking the binding, I guess. I'm not sure. I'm not sure what's going on there. Maybe the problem is not that, and we're just missing the like let's just double check before we assume. Yeah, but it seems, I mean, that's the only place that really happens. So I don't know. I don't know. All right. Well, anyway, thanks everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. And if you do want to follow along the series at home, you can always pre-order the game on handmadehero.org, and it comes with source code, so you can follow along with it. Also on handmadehero.org, I'm starting to consolidate things. I've got a little more work to do. This needs a full screen option, I guess. But on the homepage now, there's the pre-order place, there's the schedule, and there's the episode guide that you can search and stuff for things like, you know, whatever you want to know. So hopefully this will start getting better. Also, we've got the links to our other projects at the bottom and the mailing list, so it's kind of just all in one place now, and you don't have to click around, which is a little bit handier. The other thing that I would mention is two things. One, our graphic novel is on sale right now for the holidays. If you go click on Meow the Infinite down here, you can watch the trailer, and you can also get a discount on any of the versions of it that exist currently. I think I showed it at the beginning of the stream, but it's really pretty baller, and it looks awesome, and we were really happy with how good it came out. So if you're interested in that, please check it out. And furthermore, Star Code Galaxy also has the same mailing list. So for people who've been wanting to be notified when the C programming and low-level programming course, it's just generally a programming course that has everything I think you need to know in it, is ready, that's the same mailing list. So you can, as long as you put your name on our mailing list, we really don't send out anything other than announcements of when things are updated. So if there's like a new chapter of Meow the Infinite, if there's you know, a new announcement about Star Code Galaxy or about Handmade Hero, we just send them out only when there's something. So we don't really send anything else out on the mailing list. So you can just put your name in that, and you'll get well, if it doesn't go to spam, because Gmail always, of course, likes to send mailing list stuff to spam. But if you somehow manage to get Gmail not to mark it as spam, you will be able to get notified. So hopefully sign up for that if you're interested in Star Code Galaxy. We'll be sending out the information about that as soon as we are ready to have a broader access to it. All right, that's it for today. I'll be back here next week, as the schedule says. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.